Hello and welcome to part 3 of lesson 3 in Unit 7 Exponential Functions in our grade 11 University College math class. So today's lesson was all about applications of exponential functions, specifically how to deal with percentage increases and decreases and how to build those equations. We went over it here in a couple examples, which you see in the first part of this video. In the second part we went over some of the key types of questions that you might see, either like the first few here, which are just like making sure you understand where all the information comes from, and then a few worked examples here. We're going to work 3 more examples here in the third and final part of this lesson, so let's get to it. Question 5 says Ryan is saving for his college tuition. He has $2,550 in his savings account that pays 6.25% annual interest. Write an exponential equation describing this situation. Okay, so again, if we want to just set something up here, we would say that, remember we're talking about y equals a, 1, again it's a plus or minus, we don't necessarily know what it's going to be for the percentage, and then you've got x over h or t over h. So a question like this, he has $2,550 in his account, so that's where we should start for sure. That's our a value, how much he has at the beginning. Now it's 1. Now we're talking about an interest rate here. So whenever you put money in the bank, if you don't have, I was going to say if you don't have a bank, but if you don't have necessarily a lot of knowledge about sort of financial things, you gain interest. Interest gets added back on. So we are going to add our percentage. Now our percentage this time is 6.25%. So for us to express that as a decimal, that's going to be 0.0625. Now I always have students who are like, can I round that? The answer is no, you should not round this. It's a terminating decimal, which means that it has an end. This isn't 0.062555555, etc., which is like, yeah, maybe you should round that. Or at the very least put in a lot of 5s. This one terminates. It has an end, so keep the end in there. And then we have our x for time. Now this is an annual interest rate, so we're talking about this in terms of years, and this happens over the course. 6.25% is added per year, so that is going to just be x over 1, so we'll just leave it as it is. And how much money will Ryan have in his account 6 years from now? So for us, this is a simple matter of substituting in 6 right there, so let's do it. 2002, or it was I think I made a mistake there. It's 2,550. Oh, good. Caught that. All right. Newly amended. Let's see. So 2,550 times 1.0625 to the exponent 6 years, I think it was. Yep, 6 years. It's going to equal 3,000. This is money. So $3,668.71. So this is money. I'll definitely do this to 2 decimal places as opposed to 10. Okay, so building an equation in this scenario, doing the calculation, hopefully this is becoming pretty straightforward now. Let's look at another example here from the first page. A used car was purchased for $12,329 this year. Each year the car's value decreases 8.5%. Write an exponential equation describing this situation. Okay, so here, purchase the car for $12,329. That'll be my a value. So we see that we're going to be decreasing here. Another word for that is depreciation. So we're going to be subtracting this value from 1, and there's our percentage. So let's start building here. So we've got y equals 12,000, oh, don't remember, 329, $12,329, 1 minus 0.085 to the exponent, we don't know yet. So I guess x over however long it takes. And now we're going to do some substitution. Now again here, I know that up above I didn't actually do the addition, and here down below you don't have to do the subtraction. You're welcome to do it if you want. There's nothing wrong with doing 1 minus 0.085 to sort of figure out what you're going to get. In some ways, as I said, I think it's a little bit easier to type it into your calculator if you just have a single number there that you can multiply by, but it's entirely up to you. That would be 0.15 to the exponent x. And again, because this is happening per year, it'll be x over 1, so we'll just leave it alone. And the question's second part asks how much in 10 years will the car be worth. So we just put in the place, we substitute in for time, pardon me, we pop in the variable, we pop in for the variable 10, so 12,329 times 0.915 to the exponent 10, and that will equal, again, we're dealing with money, so $5,071.53. It's 527, so for money we'll go 53 cents. Sorry, I see another mistake. Making lots of copy mistakes today. There we go. So those are two examples that hopefully will help you understand just sort of more broadly how this works. I do want to skip over 7, 8, 9, 10, 11, 12, and I want to just do 13 here. This one here sometimes gives people difficulty just because there's a few steps involved. So let's read it. Mike is considering selling his 2004 Euclid, which is in perfect condition. That's a car, for those who don't know. Its initial value was $26,000. A local car dealer, Sam, tells him that a 2-year-old car was worth $20,000 and a 5-year-old car was worth $11,000. With further research, Mike learns from the local car guy that his car depreciates 14% each year, and he decides to use this method for his calculations. So let's calculate the price of the car after 5 years. So let's build ourselves an equation. So the value of the Euclid is, let's start with its initial value, and its initial value was $26,000. It says it right here in the question. So an initial value of $26,000, that's still the highlighter, $26,000. We are depreciating, so we are going to subtract a percentage. I think from the book, he realizes that it's going to be depreciating or decreasing 14% every year, so that's going to be minus 0.14. And the exponent here is going to be time over however long it takes. So again, this depreciates each year, so our h value is going to be 1. Let's do that little calculation just to make things easier, and then we're going to substitute 5 in for x. So we have 26,000, and 1 minus 0.14 is 0.86. And there is our x. Now, in order to determine what this the price of the car is, we need to substitute 5 years in for x. So let's do that now. 26,000 times 0.86 to the exponent 5 years equals, get that over here. So again, we're dealing with, well, it's the highlighter again, 12,231.10. So that's how much the car will be worth if you follow the car guide, Mike learns. So the B part is, does Sam offer a fair deal to Mike? So Mike says that a 5-year-old car is only worth $11,000. So Mike learned that by his calculations it would be equal to, or it would be worth $12,000 and some change. So is Sam's deal a good one? No, it's below market value. So not as good a deal that he is offering him. Okay, so that's the last question I want to do here. Tackle the rest of the questions on this worksheet for homework. And if you have any questions, feel free to email. Otherwise, we'll see you in lesson number 4.